This is R.D. Sharma solution, class 12, chapter 11. Differentiation exercise is 11.2. So this chapter is very big. The exercise is very big. Differentiate under root 1 minus x square by 1 plus x square. So in this differentiation, we assume first, because we need to apply the chain rule. So we assume that something is inside the under root. We are assuming it to be, say, y equals under root z. Now this z, this will be differentiated later on until there is nothing left for differentiation. For example, if you want to differentiate this, imaginary y equals under root z, it will be 1 by 2 under root z. You know that under root of x, the differentiation is 1 by twice of under root z. Okay. Then we differentiate this z. And z is what? dz by dx. So this is 1 by 2 under root. Now this is in the denominator. Whatever is in the equation has come in the denominator now in the first step. Basically it's 1 by under root 1 minus x square by 1 plus x square. This goes up. Under root 1 plus x square goes up, and under root 1 minus x square goes in the denominator. So this is 1 minus x square in the denominator under root, and the same thing under root will be in the numerator. But we still have to do this differentiation of 1 minus x square by 1 plus x square. So d by dx of this u by v form is v square in the denominator, v d by dx of u minus u d by dx of v. Means you can just see that u has to be in the numerator and v is in the denominator. Then we follow this kind of quotient rule. So d by dx of whatever is inside, we are just calling it as z, and we will use this. This first part is already done. Now we are differentiating the content inside the root. So 1 plus x square to the power whole square will be in the denominator. 1 plus x square now. Then d by dx of 1 minus x square it will be. So this is going to be 0 minus this is going to be 2x. So negative 2x it will be. Then minus 1 minus x square and d by dx of 1 plus x square. So same thing with a positive sign. 1 minus x square, 1 plus x square, it will be 2x only. Okay. Now you can just open this in the numerator and see what comes. Minus 2x and minus 2x cube. And here we have minus 2x and plus 2x cube. So this minus 2x cube and plus 2x cubes gets cancelled. Minus 2x and minus 2x will give you minus 4x. In the denominator it is 1 plus x square by whole square. And this was already there, which I just rounded up. This was already there, 1 by 2. So 1 plus x square, you can write it as 1 to the power half. So root is nothing but 1 plus x square to the power half. And denominator 1 minus x square to the power half, or you can just keep it like under root only. Now in the previous question, one of the previous question we have done this. So 1 plus x square to the power half, I am taking it in the denominator. This minus 2x, which I cancelled 2 with 4, and denominator under root 1 minus x square, I kept it like this. And this half power has come in the denominator. So 2 minus 1 by 2, the power gets added. It is going to be 3 by 2. So this is your final answer. Differentiate log sin x whole square. So we have y equals, say something x square, z square, or whichever you can assume. The differentiation of x to the power square is 2x. If you assume it to be some x square or z square or whichever. So d by dx of log sin x whole square is twice of log sin x. Now you have to differentiate log sin x. D by dx of log sin x will be done now. And d by dx of log something is 1 by of that something. So 2 log x sin x, d by dx of log sin x is going to be 1 by sin x. And then differentiation of sin x is what? We are doing chain rule. Sin x is cos x. So cos x by sin x is cot x. So the final answer will be 2 log x sin x cot x. Cos x sin x, we are writing it as cot x. 2 log x sin x. So log sin x is one term, cot x is another term. This is your final differentiation. These are the differentiation result we have used. Now differentiate under root 1 plus x by 1 minus x. So we have just done a question 1 plus x square and 1 minus x square. So we have done a more complicated version. So I hope you will be able to do it. The answer is in front of you. You can try. Any problem you can just ask. Okay. So this is the same, one of the same question we have already done. And this is also a kind of that type of question only without a root. But the idea will remain same. So we'll do this. Sine of something. So y of sine of something, this you can call it as, say, z. The sine of something is going to be cos of that thing. That thing, call it as z or whichever character you can want. So d by dx of this sine theta is cos theta. Now the theta or z or whichever you are asking, you have to differentiate that as well. So cos of 1 plus x square by 1 minus x square. Now d by dx of 1 plus x square by 1 minus x square also has to be done. So d by dx of 1 plus x square by 1 minus x square. And we will apply the quotient rule as we have applied in the previous questions. So in the denominator it will be 1 minus x square to the power square. Then 1 minus x square will come here. D by dx of 1 plus x square, that is 2x, minus 1 plus x square, it is d by dx of this 1 plus x square, 1 minus x square, sorry. It is going to be minus 2x, so I change the sign in between. Okay, so let us multiply this. 2x you can take common, 1 minus x square plus 1 plus x square will come, x square gets cancelled, and 1 plus 1 is 2, so 2 into 2x is going to be 4x. So the numerator will be 4x, 1 plus 1 is 2. So this is going to be 4x divided by 1 minus x square and to the power whole square. So 1 minus x square to the power whole square, and here I'll just write the square, okay, in the denominator. So cos 1 plus x square by 1 minus x square, this is going to be your final answer. This is 1 minus x square whole square in the denominator, please remember. Okay. So this kind of differentiation, and we have used the normal version and then the quotient rule and the chain rule. Differentiate e to the power 3x and cos 2x. So there are two separate functions. One function you can call it as fx, the other function you can call it as gx. So when you differentiate these two functions with fx into gx, please remember d by dx of cos theta is minus sin theta. E to the power x differentiation remains the same. There is no change when you take the differentiation. So one is fx, one is gx. So fx will write e to the power 3x, that d by dx of cos 2x, cos theta is minus sin theta. So you have minus sin 2x. Now you have to differentiate 2x also. You cannot leave 2x. Differentiation of 2x is 2. Right? Then we have subtraction, and this, I know that the differentiation will give you something like that. So cos 2x, e to the power 3x and then 3x also. Okay. So when you see the result here, it's going to be e to the power 3x, you can take common. So this you can write first, 3 cos 2x and minus this 2 sin 2x. So here this product rule we have applied the chain rule. So, and we know the differentiation of e to the power x and cos theta. So 2x and 3x, they both also have to be differentiated as per the chain rule. Differentiate sine of log sin x. Sin x, the differentiation is cos x. Log x, the differentiation is 1 by x. So y equals sine. So whatever is inside, call it as z by just for now. So dy by d of x or z, sine x will be cos x. So cos log sine x it will be. And then differentiation of log sine x. In chain rule, now you have to differentiate the log sine x. So d by dx of log sine x will be, because log x is 1 by x. So log sine x will be 1 by sine x. Whatever is inside log, it is going to be in the denominator. So this is 1 by sine x. Now you will not leave it here. The differentiation of sine x, because the chain rule you are following, the differentiation of sine x is going to be cos x. And cos x by sine x, you can write it as cot x. So the final result will be cot x cos log sine x. Okay. This is your final result. So cot x cos log sine x. And the way you have to write, because it can be your exam, it can be your classwork, all these English you have to represent. The basic is that you might be knowing how to solve the question, but you have to describe it to your examiner that I know how to solve it. So the maximum you will write, the maximum you will say represent. For example, your IQ may be 90 or 900, but the person who has IQ of 70 and who writes very well, who represents very well, is far better than the person who is having a very high IQ. Because having mind and not able to represent it, what you know, is equivalent to a person who knows little but he can explain better. That is why I always show the answer. This is because ultimately you have to answer. Differentiate e to the power tan 3x. So e to the power x, the differentiation will be e to the power x only. So e to the power z, differentiation will be what? E to the power x only. So e to the power tan 3x it will be. Now what is the differentiation of tan 3x? Because you have to use the chain rule. D by dx of tan 3x is, tan theta is sec square theta. So it will be sec square 3x. So e to the power tan 3x, sec square 3x, and then the differentiation of 3x. And it is 3 only. So you can write either way you want, but just write the answer so that the 2 or 3 terms, they do not seem to be combined, or you cannot differentiate. So the better is to 3 e to the power tan 3x and sec square 3x. Alright. So whatever you are applying, you just write it here. If you see in the answer, the product rule or this is not written. You have to write it there properly. E to the power under root cot x. So this, I think this kind of question we have already done. So e to the power x is simply e to the power x. So e to the power under root cot x will be e to the power under root cot x only. First differentiation, first step. So e to the power z, e to the power under root cot x. Now you have to differentiate under root of cot x. So assume it to be under root of z or something. So d by dx of this under root of something is 1 by 2 root under root something. It will be 1 by 2 under root cot x. This one, okay. So it is basically cot x to the power half. So when you differentiate it, it will be half into cot x to the power half minus 1. That is half into cot to the power minus half. Minus half goes in the denominator, and that will give you under root of cot x. Twice of root cot x in the denominator. Okay. Now the third step is cot x. You have to differentiate cot x. Cot x is minus cosec square x. This is a standard rule. So final answer is 3 terms. E to the power under root cot x, which we got just by saying e to the power theta kind of differentiation. Then we took the under root cot x, which got us twice of under root cot x, and then the minus cosec square x, which has come from differentiation of cot x. So wherever you are doing chain rule or differentiating or final result, each has to be written in the way which has been prescribed here. And you know the differentiation of whichever element, whichever term, whichever identity, trigonometry or algebra, this also you have to write, and making a round, or you can say making a square around it will always be welcome. Differentiate log sin x divided by 1 plus cos x. So we will apply first the normal thing, that is log theta, 1 by theta. Then we have to apply the quotient rule, because we have to differentiate sin x by 1 plus cos x. So y equals log of something, it is going to be 1 by of something. So this sin x by 1 plus cos x will come in the denominator. So 1 plus cos x will go in the numerator. So it will be 1 plus cos x by sin x. Okay, differentiation of log x I am saying. So this term we have already achieved. Now the second will be to differentiate sin x by 1 plus cos x. And differentiation of sin x by 1 plus cos x, that is u by v form. And this is going to be a quotient rule. Log x is simply 1 by x, which I already told you. And the answer also we got of this thing, 1 plus cos x by sin x. So in order to differentiate this, assume this sin x to be u, 1 plus cos x as v. So sin x by 1 plus cos x, u by v. You see on the right, if you are able to write this quotient rule to the examiner, then also it will be very well appreciated. So 1 plus cos x in the denominator square, 1 plus cos x here, d by dx of sin x will be cos x only. And then we have a subtraction sign. Then we write the sin x like that. And 1 plus cos x is going to be, 1 will be 0, cos x will be minus sin x. Okay? Cos x is minus sin x. So just change the sign, write a sin x here. So you can call it as sin square x. Now you see in the numerator, I am not writing the denominator. Let us solve the numerator first. So cos x into cos square x plus sin square x. Now cos square x plus sin square x is what? It is going to be 1. So replace it by 1. So you get 1 plus cos x. So 1 plus cos x it will be. And in the denominator you have 1 plus cos x whole square. So you can cancel one of it. So in the denominator you have 1 plus cos x. And this is 1 plus cos x by sin x. It was already there. So 1 plus cos x by sin x. Now you can just cancel this 1 plus cos x and 1 plus cos x. So 1 by sin x will come. And 1 by sin x is what? It is cosec x. It is going to be cosec x. So this is your final answer, cosec x. So write that you have used the chain rule and the quotient rule. And if possible, also write the quotient rule, if possible. Okay, now these are all the combination possible. So log of theta, then you have theta in the root, and then you have inside that you have another term, 1 minus cos theta by 1 plus cos theta. So those who have already done and they just want to go ahead, they can just refer to the answer and just try solving themselves. So or then those who want to learn or understand, let us see y equals to log z. Log z, this whole root is the log z. So it will be 1 by under root of 1 minus cos theta by 1 plus cos theta. So 1 plus cos theta under root will go up, and under root of 1 minus cos theta will be in the denominator. So 1 plus cos theta in the numerator, 1 minus cos theta in the denominator. Alright? This is the first step. The second step is to do the differentiation of under root. So the under root is what? Under root, if under root theta you have to, or under root x you have to differentiate, it will be 1 by twice of under root of that content. Okay? This is just 1 log x. Log x is 1 by x. So this just we have got the first step. Now we have to do or differentiate the under root of 1 minus cos x by 1 plus cos x, assuming it to be just root of something. And root of something is 1 by twice of this content. So 1 minus c, 1 plus c, 1 minus cos theta, 1 plus cos theta to the power half. So half will come in front. And 1 minus c by 1 plus c to the power half minus 1. That is half minus 1 is negative half. And it will come in the denominator. 1 minus cos and 1 plus cos come in the denominator. Okay. So this is going to be 1 minus cos. And 1 plus cos will go in the numerator. But this will be in the denominator with the root. Okay, so let me write it all of it. 1 plus cos in the numerator, 1 minus cos in the denominator, and we have a 2 in the denominator. Under root 1 plus this one, under root 1 plus cos will go in the numerator. This 1 minus cos will be in the denominator, and 1 by 2, of course, as I said. Now under root of something with under root of something, same thing is going to be, the under root will be eliminated. And since we have this 1 plus c, that is 1 plus c whole square, 1 plus cos theta whole square. This under 1 plus cos into 1 plus cos, the under root it will go inside. It will be 1 plus cos square and under root, this gets cancelled. So 1 plus cos, and same in the denominator. Under root 1 minus cos, under root 1 minus cos, under root get cancelled. Because 1 minus c square it will be if you multiply inside. And 2 will be cancelled with 1 by 2. So finally we got 1 plus c by 1 minus c. The c is of course cos theta. But this is just a second step. Now you have to differentiate 1 minus cos theta by 1 plus cos theta. This also you have to do. So we will apply the quotient rule, QR. So 1 minus cos theta by 1 plus cos theta. So we have 1 plus cos theta in the denominator, 1 plus cos theta it is. And then differentiation of 1 minus cos theta. So let me do it here, d by dx of 1 minus cos x. So 1 will be 0. Cos is minus sin theta. Negative is already outside. So it will be positive sin theta. Cos theta is minus sin theta. Please remember, sin theta differentiation is cos theta. And cos theta differentiation is minus sin theta. Alright? So you just have to write sin theta here. So let me write sin theta. I am taking the short form. 1 minus cos, and then we have 1 plus cos. Differentiation of 1 plus cos is what? Cos theta is minus sin theta again. Okay. So minus gets plus here, and then we have again a sin theta. Now just open this. Or you can take sin theta common, 1 plus cos and 1 minus cos, cos gets cancelled, you will get 2. So 2 into sin x, you can see here also. Or you can just open it. 1 plus sin into cos plus sin, sin plus sin cos plus sin minus sin cos. So this sin cos gets cancelled. 2 sin x in the numerator and 1 plus cos whole square. Now write it here. 2 sin x. 2 as I am writing sin, s for sin and c for cos. So 1 plus c, this goes out, cancelled, 2 gets cancelled. So you have in the denominator 1 minus c and 1 plus c. So you have a sin x in the numerator and 1 square minus c square, a plus b, a minus b. 1 minus c square is 1 minus cos square theta is sin square theta. So just write sin square here, just cancel this sin and sin square. 1 by sin square is 1 by sin x in the denominator. It is going to be cosec x. So this is your answer. Cosec x will be the final answer. Okay. This we are going to take in the next discussion. Till then, thank you so much and take care of yourself.